Okay, ladies and gentlemen, we're taking a look at inverse functions. So what we have here is we have inverse functions are the undo functions. What they do is they take an original function and they take the range back to its domain. So it's an inverse function. This is the notation for it. That is not an exponent. This is not true. It's not an exponent, but it stands for the inverse of function f of x. So if we have the domain of f of x, and if I use some colors to help notate what I'm doing here, there's the domain of f of x, there's the range of f of x, and f of x is going to take all the elements of the domain over to its range, okay? Now the inverse would then take all of the elements of the range for f of x, which becomes the domain of the inverse, and it's going to take it to its original domain of f of x, or in this case, that'll be the range of the inverse. As we talked about in class, if you have a set of ordered pairs, it's pretty simple just to give your the answer of the inverse in terms of ordered pairs, where the domain becomes the range and the range becomes the domain. So that would be 4, -3, 7, 0, and 9, 2. Okay? And what we have as well is we could have a mapping notation for this. The mapping notation would simply be y, x. And something that we've shown a couple of times in this course is the domain and the range will be interchanged. And that's what we're talking about here. So that's this first page. Read it over. Make sure that it makes sense. And I think with most of you in class, we got done the first example, but I'll do it again just for the to have this a complete note of everything that we've done. This video will represent the complete note. So graphically, when we talk about an inverse, it is the reflection of your original curve f of x in the line y equals x. So the line y equals x, now we spent some time last week actually thinking about what that means. If I have a line y equals x, that means that the x value and the y value have to equal each other. So if I have a point 1, it's y, well, if I have an x coordinate of 1, its y coordinate would be 1. If I have an x coordinate of 5, the y coordinate is 5. If I have an x coordinate of -7, then the y coordinate's -7. So plotting just some of those, 5 and 5, 0, 0. All I need are 2 points really to be able to graph a line, but a couple of extra make sure that I line it up properly. And so lining up those 3 points, I'm able to put in the line y equals x. And there it is. So what we want to do now is we want to graph f of x equals 4x plus 3. Now, if I paid attention in grade 9, the way we'll sketch that is to say that the y-intercept is going to be 3, because we can read it right off of there. So the y-intercept is equal to 3, which means that it's going to cross the y-axis at 0, 3. And you'll notice that it has a slope of 4, which is 4 over 1, which is the rise over run. So that means that if I want to plot this line, I'm going to go to the point 0, 3, which is here. And I'm going to go over 1, and I'm going to go up 4. 1, 2, 3, 4. I'm going to go to there. And I would do the same thing again. Go over 1 and up 4. 1, 2, 3, 4. So what that gives us is a nice line connecting those 3 points. And that is f of x. And your grade 9 teachers would be so proud of you. And look, you have your little rate triangle there. Isn't that nice? Now, I don't teach grade 9 very often, so I'm not going to graph it that way. This is the way I'm going to graph it. I'm going to make a table of values. All I need are 2 points, x and 4x plus 3. So I'm going to choose 0 to put in. Put in 0 for x, and I'm going to get 3. I'm going to choose 1 because it's easy. Put in 1 here, and I'm going to get 7. Look at that. I go and I plot the point 0, 3. There it is. I plot the point 1, 7. There it is. Line it up, and there's my line. So there you go. Grade 9 method of doing it and my way of doing it. Both work. Now let's sketch this. We want to sketch the inverse. Now we know that the point notation for an inverse is the domain becomes the range and the range becomes the domain. So what I'm going to do is take my 2 points, 0, 3, and it's going to become 3, 0. This point here, 1, 7, didn't write that very nicely, but there you go, will become 7, 1. And so, plotting those points, 3, 0 is here, 7, 1 is here. All I need are 2 points to be able to graph a line, as long as I'm particularly careful about how I do it. And here is that inverse, which is a different line. So this one up here is f of x. It's your original function. This one down here is your inverse function. Notice that it's a reflection in this line, y equals x. If I was to fold this over, you'd notice that all of the blue ones would be lining up on the green ones, and all of the blue one was line up with these green ones. And as we've discussed in class, what's happening here is that you're getting equidistant these 2 points from this line. That's the reflection. It's reflecting over. So points down here get reflected up. These points get reflected down. Notice this point here, which lies on the line y equals x, doesn't move. It's what we call an invariant point. But that would be the point where the y and the x are both the same value. We could estimate here that it's -1, -1. And if that's the case, if I interchange the domain and range, -1, -1 becomes -1, -1. And it stayed there. So it's actually on both of the curves. Now, algebraically, this line here obviously has an equation. I could try to read it from the graph like I did in class, but you'll remember that it didn't work out so well. I estimated this to be -1, and it turned out not to be. So a more accurate method would be to look at this algebraically. What we're going to do is we're going to follow these 4 steps. The first step is we're going to replace f of x with the variable y. The second step is we're going to interchange the x and the y variables. And then next we're going to isolate or solve for y. And then finally we're going to put it back into inverse notation. This step here is simply a step in notation. This step here is simply a step in notation. We're actually not doing anything except changing the way we write it. This step here is going to be the step where we do domain and range, interchange. Okay? And this step here is going to be algebra. So let's take a look at how this is going to happen for this particular function. Notice that this function was my f of x, and what we're going to do now is we're going to determine the inverse for this function. In other words, the equation of this line. So, you start off with your original function. The first step says replace f of x with the variable y. That's simply notation. We didn't do anything special. We just changed f of x for y. Next, interchange the variables. What that means is where there's a y, make it an x, and where there's an x, make it a y. So that's the step of interchanging the domain and the range. And I like to show that by showing that little symbol there. So the domain became the range and the range became the domain. Next, we need to isolate. You want to isolate for y. Okay, so you need to move everything around. So I'm going to move that 3 over to the other side. I'm going to divide both sides by 4. And I'm done. What I need to do now is another notation step where I change this back into the inverse notation, and it's going to be x minus 3 divided by 4. So this step in here was your algebra to isolate for y. Lastly, we had the notation. That's it. Real simple. So this equation is this line. So another way to write this equation, if you want to see it in y equals mx plus b form, is x over 4 minus 3 over 4. So this intercept, is negative 3 over 4. So it's negative 0.75, and my slope is 1 over 4, which means I'm going to go over 4 from this point. From this point, I'm going to go over 4. 1, 2, 3, 4, and up 1. And notice I started up a little bit, so I should be above this x-axis a little bit. Maybe this is a better point to move. Negative 1, negative 1. Let's see if negative 1, negative 1 fits on this curve. Let's go back here. Let's put in negative 1. Put in negative 1, I get 4 times negative 1 is negative 4, plus 3 is negative 1. So that does lie on this curve. That is that point right there. When you do the transformation, negative 1 becomes negative 1, negative 1. Well, okay. So that is that point on this line, which means that this point right here is negative 1, negative 1. So if I want to test my theory here, see this slope here? That slope is the same as 1/4 x, which means the slope is 1 over 4. The rise is 1 over a run of 4. So I'm going to go to this point, and I'm going to go over 4. 1, 2, 3, 4, and I go up 1. 1, 2, 3, 4, and I go up 1. So that way, we have just shown that this is, in fact, the equation for this line. Here's a way of finding it using the graph. Here's a way of finding it using algebra, and the two are intimately related. Okay, that's the end of the first video. We'll do another one with the next example.